Assalamu alaikum, grade 10 students. We are going to explain part 3 of chapter 4, vector coordinates. Objectives: prove collinearity of vectors and points in coordinates plane. Prove parallelism of lines in coordinates plane. Materials: textbook, pens, draft papers, copybook, and calculator. Collinear vectors. Recall, given two vectors u and v, non-zero vectors u and v, we say that u and v are collinear if and only if there exists a real non-zero number k such that u equal kv. This is agreed upon. Property 1, given the two vectors u and v, we have u equal kv, where k is a real number, so xu equal kxv and yu equal kyv. So by comparison we get that k equal xu over xv equal yu over yv. Therefore, if u and v are collinear vectors, then xu over xv equal yu over yv equal to a constant number and vice versa. Example 1, given the two vectors u and v, are u and v collinear? Justify. Solution: xu over xv equal 3 over 30 equal 1 over 10, yu over yv equal 1 over 10. So by comparison they are equal, so we conclude that they are collinear vectors. Application 1. Please stop the video a few minutes to solve this application. Here in part 1, since the ratios are not equal, so the vectors are not collinear. Part 2, calculate the value of m so that v and w are collinear. Since v and w are collinear, so we can write these equal ratios. We get that 1 over m equal 4 over 2 cross multiplication, so m equal 1 over 2. Collinear points. Definition 2, 3 points A, B, and C are collinear if and only if A, B, and AC are collinear and having a common point A, or A, B, and BC are collinear and have a common point B, or AC and BC are collinear and have a common point C. Example 2, let A, B, and C be 3 points in reference system. Are A, B, and C collinear? Solution: here we find the coordinates of A, B, and BC. You can find A, B, and AC, or AC and BC, but here we are choosing A, B, and BC. Then we find the ratios. The first ratio is xAB over xBC, which is equal minus 2 over 3. YAB over YBC equal minus 2 over 3, so they are equal. So the vectors AB and BC are collinear and have common point B. Therefore, A, B, and C are collinear. Application 2. Please stop the video a few minutes to solve. Here in part 1, we want to find in terms of m the coordinates of AC. AC having coordinates m minus 1, minus 4. In part 2, calculate m if C belongs to line AB. If C belongs to line AB, so they are collinear points A, B, and C. So we can write equal ratios. xAC over xAB equal YAC over YAB. We get that m minus 1 over 3 equal minus 4 over minus 2, cross multiplication, then m equal 7. Parallel lines. Definition 3, two lines AB and CD are parallel if and only if AB vector and CD vector are collinear. Example 3, given the two vectors AB and CD, prove that the two lines AB and CD are parallel. So we have to check if AB and CD are collinear. We check if equal ratios. xAB over xCD is equal to 2. This is the first ratio. The second ratio, YAB over YCD equal 2. So they are equal ratios. Then the vectors AB and CD are collinear. Thus AB is parallel to CD. Application 3. Please stop the video a few minutes to solve. In part 1, we find the coordinates of AB, CD, AC, and BD. In part 2 is AB parallel to CD. we check if the ratios are equal. We have this ratio is 1 over 2 and this ratio is also 1 over 2. So the vectors are collinear, so the lines are parallel. In part B, does the vector AB have the same sense with the vector CD? Here we have to find the sign of the ratio. The ratio is 1 over 2, its sign is positive, so they have same sense. AB equal plus half CD, so AB and CD have same sense. Part 3, if the line AC parallel to line BD, also we have this ratio is 1 over 5, while the other is 0, so they are not equal, so the lines are not parallel. Part 4, deduce the nature of quadrilateral ABDC. ABDC is a trapezoid since one pair of opposite sides are parallel. Summary for this chapter. I hope you understood the lesson, and good luck and success.